about three important reagents. We are comparing these reagents with respect to each other. Yesterday we have completed beer vinegar oxidations, okay, and other applications of metachloroperbenzoic acid in the presence of different condition. So this is we have already completed. Carbene concept we have already completed. Now today we are going to talk about three important type of reagent, that is organolithium, organomagnesium, and organocopper. So among these three, organolithium, what are its applications, where it is react, what is its selectivity? So we are making focus on that point. So when we talk about organolithium, then what happens? Reagents become, all these are the nucleophile supplier. Organolithium, that is RLI. This is we call as organolithium. Now what happens? Here this is having R minus nucleophile and lithium plus. R minus and lithium plus. Second reagent is Grignard reagent. And Grignard reagent, you can say it is nothing but organomagnesium. It is RMGX. Again here see it's R minus and MGX plus. Metallic part is a plus. All these are the nucleophile supplier, alkyl nucleophile supplier. And third one is Gilman reagent. That is nothing but dialkyl copper lithium, R2CuLi. Again this is a R minus supplier. So nucleophile become R minus. Now all these reagents which are react in alpha beta unsaturated carbonyl compound. This is a alpha beta unsaturated carbonyl compound. So there is two double bond. One is carbon oxygen double bond. Another one is alpha beta double bond. So alpha carbonyl carbon is electron deficient. Alpha carbon is electron rich. Beta carbon is electron deficient. So nucleophile R minus may be added. R minus can added either at beta carbon or at carbonyl carbon. So what happens? So where it is added, so this can be decided using reagent, whatever we have written here. So if you talk about lithium, organolithium, then this is a highly reactive reagent. It is highly reactive. This is more reactive. And whenever it is more reactive, then it is reacted at different site. So therefore, there is no options for selection. So it is less selective. Reaction on carbonyl group. Reaction take place. React on carbon oxygen double bond. It is so that therefore nucleophile is added at carbonyl carbon, not beta carbon. Okay. For example, if you can have a CH2 double bond CH, 3 double O CH3, and if you do reaction with methyl lithium, then CH3 minus become added at carbonyl carbon. So oxygen gets converted to OH. So in short, the reaction takes place at carbonyl carbon. So this is about application of organolithium. As compared to this one, Gilman reagent, dialkyl organo, dialkyl copper lithium. This is just a bulky reagent, you know very well. So it is a less reactive, and if it is less reactive, then it is more selective. It is more selective. Reaction take place on reacton R minus added on beta carbon. So reaction take place at beta carbon, R minus added on beta carbon itself. For example, if you having RCH double bond CH, C double O CH3, then if you carry out reaction with CH3 twice, CuLi, then CH3 minus is added on beta carbon in this way. So this double bond is comes to here. So you are getting this intermediate RCH OLi The next step you can do hydrolysis and followed by tautomerism. So hydrolysis will give you OH and then you can do tautomerism. Then you are getting what you can do hydrolysis followed by tautomerism. So again hydrogen is shifted to here. So you are getting beta nucleophilic product. Nucleophile is added at beta carbon. Now see this is again see Grignard reagent is the intermediate reagent. Its application is between these two. This is one reagent which is added at carbonyl carbon. This is highly focused on carbonyl carbon. This is highly focused on beta carbon. But here reaction takes place at both the carbons depending on see bulk, depending on the nature of substrate as well as you can say nature of now this is added on both. Now what happens in this reagent? It is a moderately reactive. This reagent is moderately reactive. One is fast, more highly reactive, second is less reactive, third one is this is moderately reactive. So R minus react at both, react at either carbonyl or beta carbon, depending on bulk. CH3 MgCl, what happens? See here, carbonyl carbon is less bulky because see here it's a very simple hydrogen is there, so its bulk is less, and nucleophile is also less bulky, and therefore CH3 minus is added at carbonyl carbon. This is added here. So you are getting CH2 double bond CH, COH, CH3H in this way. But if you having see bulky reagents, suppose you are having see this type of bulk, this type of bulk is there, phenyl ring is there, this is bulky. Then you can have a reaction which is taking place at beta carbon. CH3 minus is added on beta carbon. So if you having C bulk, then CH3 minus is added at beta carbon. Suppose reagent is like this type. This group is bulky, and when you react it with CH3 MgBr, then CH3 minus is added at beta carbon. Double bond comes to here, this is converted to OMgBr, followed by hydrolysis. The byproduct is MgOHBr, and main product is CH2, CH3, CH, double bond COH, and main product is, this is on hydrolysis. So you are getting C beta methylated product. Nucleophile is added at beta carbon. The reagent is bulky. So depending on whether it is bulky or less bulky, you can have a product. So these are the three very important reaction, three important reagent. Now we check its detailed application. First we go for Grignard reagent. Detailed application. So apart from this one, see, apart from that common applications, now we are having see one of the detailed applications, that is nothing but applications of Grignard reagent. Grignard reagent is useful to synthesize alcohol. If you want to synthesize the alcohol, then Grignard reagent is very important. It may be primary alcohol, secondary alcohol, okay, whatever, and most of reaction which is taking place with carbonyl compound. So I'll give you certain applications. Suppose if you react Grignard reagents with formaldehyde, this is a very simple aldehyde, formaldehyde. So formaldehyde will give you primary alcohol. When it react with RMGX, then R minus is added to here. This is converted to OH. You are getting RCH2OH. That is primary alcohol. Second one is other aldehyde, that is any other aldehyde apart from formaldehyde, like this type of aldehyde, other aldehyde on reaction with Grignard reagent gives secondary alcohol. It gives secondary alcohol. Third one, ketone give you ketone on reaction with Grignard reagent. The ketone on reaction with Grignard reagents give you tertiary alcohol. So if you want to synthesize primary, secondary, and tertiary alcohol, then this is very, very important reagent. This is one of the important reagent. Now you tell me, suppose I want to synthesize primary alcohol, that is butanol, CH3, CH2, CH2, CH2OH. Then which reagents I will going to use? Anybody please? Suppose I want to prepare butanol, CH3, CH2, or you can say propanol. If you want to prepare one propanol, then which reagent is useful? Anybody?
Primary alcohol.
પ્રાઇમરી છે ને જો OH ગ્રુપ જે કાર્બન સાથે હોય એક સાથે જોડાયેલો હોય, so it is called primary alcohol. So which reagent is useful?
Grignard.
Grignard જ છે, બટ કયું રિએજન્ટ એમ કહું છું? CH3MgBr કે ઇથાઇલ મેગ્નેશિયમ બ્રોમાઇડ કે ફોર્માલ્ડિહાઇડ કે કીટોન કે એસિટાલ્ડિહાઇડ? See, it is very simple. CH2OH, this is comes from formaldehyde. So one of the reagent, one of the reagent is formaldehyde, and second one is
C2H5MgX.
C2H5MgX. Good. CH3CH2 બાકીનો જે ભાગ રહેતો હોય એને મેગ્નેશિયમ સાથે લેવાનો. R is equal to this group. So you are getting CH3CH2CH2OH. Suppose if you want to synthesize secondary alcohol, acid 2-propanol, then what happens? CH3CHOH. CH3 આ સિન્થેસિસ કરવો છે, કયું રિએજન્ટ જોઈએ?
Aldehyde.
કયા કયા આલ્ડિહાઇડ બોલો? નામ જ બોલવાનું. તો આ આલ્ડિહાઇડ જ છે, બટ ફોર્માલ્ડિહાઇડ give you primary alcohol, other aldehyde give you secondary alcohol. છૂટું પડી દઉં ગ્રિગ્નાર્ડ reagents and both. CH3MgX અને આલ્ડિહાઇડ કયો?
CH3COOH.
Acetaldehyde. And react with CH3MgBr. Then you are getting, on hydrolysis, you are getting secondary alcohol. Suppose if you want to synthesize tertiary alcohol, CH3CHOH. ચલો ટર્સરી આલ્કોહોલ સિન્થેસિસ કરવું હોય તો કયું રિએજન્ટ યુઝ કરશો?
CH3COO. CH3MgX.
એક તો CH3COO એસિટોન પ્લસ CH3MgX. So you can have a CH3COOCH3 when it reacts with CH3MgX, MgBr. Then the CH3 is added to here. Apart from this, other application is if you want to synthesize primary alcohol, so one of the option is formaldehyde. One of the option is formaldehyde. But the second option is you can have a epoxide. Epoxide can react with Grignard reagent. to give primary alcohol. For example, say RMGX. This is a Grignard reagent. When it reacts with this epoxide, so R minus make attack here. This bond is open up. And this is on hydrolysis gives primary alcohol. So again, see, you can have one more options over here. If you want to synthesize propanol, then you can also synthesize it using propanol. If you want to synthesize, then R is equal to CH3. The second option is you can react CH3MgX with epoxide. Then you are getting CH3, CH2, CH2OH, propanol. One propanol. So this is the alternate reactions where you are getting primary alcohol. So this is the fourth applications of Grignard reagents, that is reaction with epoxide. Then if you want to synthesize carboxylic acid, then you can add this Grignard reagent RMGX into CO2. When it reacts with CO2, that is this one, say CO2, then R minus is added to carbonyl carbon, and this is converted to OMGX. RCOO as it is OMGX. This is on hydrolysis gives RCOOOH. Suppose if you want to synthesize acetic acid, then you can have a CH3MgBr and react with CO2. So it gives acid with increasing one more carbon. Okay. Suppose if you want to synthesize benzoic acid, then you can take phenyl magnesium bromide. When it reacts with CO2, so it gives benzoic acid. Now, if you want to synthesize alkane, then what happens? RMGX. When it reacts with H2O, hydrolysis is simple. H2O having H plus and OH minus. So what happens? See, R minus is combined with H plus, it gives RH, alkane. Alkane is the product. And OH combined with MgX and gives MgOHX as a byproduct. So see, these are the various applications of Grignard reagent. You can add Grignard reagent into oxygen. What happens? So 2 moles of Grignard reagent is required. RMgX. If you're having 2 moles, if you want to react it with Grignard reagent, RMgX 2 mole of this reagent. When it is added to oxygen O2, is nothing but oxygen oxygen double bond. So it gives 2 moles of ROMGX, which is on hydrolysis gives 2 moles of ROH, and byproduct is MgOHX. Okay, so whenever oxygen is there, so it undergoes utilization of 2 mole. It is also gives alcohol. And last one is when you react Grignard reagent RMgX with cyanide RC triple bond N. So nitrogen is negatively charged, carbon is positively charged. So R minus is added here. It gives imine first, imine upon hydrolysis. This is called imine. Imine upon hydrolysis. So oxygen is supplied to here. That gives ketone. And OH minus is OH, 2 hydrogen is supplied over here. 2 hydrogen is supplied with nitrogen. So it gives MgNH2X, NH2MgX. So this is the way you can have various application of Grignard reagent. This is the way to carry out different applications of Grignard reagent. Now next we go for Gilman reagent that is applicable to have a reaction at beta carbon. Gilman reagent R2CuLi, Gilman reagent. It is added at beta carbon. For example, very important reagent. આ ટાઈપના એક્ઝામ્પલ મેક્સિમમ ટાઈમ પૂછાતા હોય છે એક્ઝામમાં. This is alpha beta unsaturated compound. So when you react with CH3 twice, CuLi, then CH3 minus is added to beta carbon. So you are getting OLi, and here it's a CH3. Now suppose this is added from front side. The next time if any reagent is available, for example, if you having ethyl reagent with departing group, then again next time alpha carbon will react. So you are getting this group which is remains front side, then further reaction take place which is at on back side. This is a major product, but very important thing is here, see first reaction taking place at beta position. This is the applications of Grignard reagent, or sorry, Gilman reagent. Beta carbon is a very important. So you can carry out reaction at beta carbon. Suppose you are having here phenyl ring. When you react with methyl magnesium CH3 MgCl in the presence of CuCl, so it is also nothing but a pair is nothing but Grignard reagent. This is in a first step, and this is a second step, reaction with allyl halide. And what you can do first, see CH3 minus is added at beta carbon. અને એક્ઝામમાં પૂછાઈ ગયો છે, it's major product. So CH3 minus is added at beta carbon. And next time when you react it with allyl, methyl group is less bulky, so it remains towards incoming nucleophile at alpha position. Next time it is react with allyl, so this alpha carbon which make attack here, so you are getting this is the product. Methyl group less bulky છે. આમ તો મિથાઇલ ગ્રુપ જે અટેક કરે છે બંને ઓપોઝિટ સાઈડ જ રહેવા જોઈએ આ રીતે જ, બટ એવો ઓપ્શન આપેલ નથી પેપરમાં એટલે આપણે આ ચૂઝ કરતા હતા. ખરેખર તો મિથાઇલ અને આ બંને આ ધીસ ઇઝ કરેક્ટ વન, બટ પ્રોડક્ટ એક જ ઓપ્શન્સ આપેલ છે પેપરમાં. આ બીટા કાર્બન સ્ટીરિયોકેમિસ્ટ્રી મેન્શન કરેલ નથી. સો ધીસ ઇઝ ધ કરેક્ટ વન. So see in short reaction which is taking place at beta carbon. This is very important. That is called Gilman reagent. નેટ 2012 ડિસેમ્બર 2012નું પેપર જોશો તો એમાં આ ટાઈપનું એક્ઝામ્પલ પૂછાઈ ગયેલ છે. મેજર પ્રોડક્ટ ફોર્મ ઇન ફોલોવિંગ રિએક્શન કરીને છે ક્વેશ્ચન. We have to predict its major product. This is on reaction with CH3 twice CuLi in the presence of diethyl ether to predict major product. So see it's a very simple first reaction which is taking place at beta carbon because it is Gilman reagent. So CH3 minus is added over here. Second time, see there is no any other reagent is available, but internal departing group iodine is there. So next time reaction taking place at alpha position in this way. Now this is a CH2, CH2 again. So internal reaction which is taking place, so this become major product. This become major product. So this is called how C-Gilman reagent is work. So this is the applications of important applications of Gilman reagent. Which part will going to combine with this one? See, this is very important. Original stereochemistry. In case of see this, one of the question is asked in GATE exam is like this one. GATE no paper जो है approximate in 2011 something, 11 or 12. When it react with Cu, this is a reagent, R reagent. Twice Li. This is a Grignard reagent, OSMe. This is Grignard reagent, and normal butyl phosphine, tributyl phosphine, in the presence of THF. Second step is reaction with this one. So what is its major product? Question is predict the major product. So these are the options. Get exam 27 something cutoff હોય વધારે ના હોય. Okay, cutoff become either 27, 28 like that. So એમાં એટલે આવા ક્વેશ્ચન્સ છે બહુ ઇમ્પોર્ટન્ટ ક્વેશ્ચન થઈ જાય. એટલી જો બારીકાઈથી પૂછે છે ખાસ જુઓ તમે. So this is the way. See, this is one of the option. ઘણા સ્ટુડન્ટ્સ તો ઓપ્શન જોઈને જ છોડી દેતા હોય છે, બટ સી આમાં ચેન્જીસ બહુ માઇનર છે. Changes which is take place in reaction, it is very minute. Option number B. Option number C. Which one is correct according to you? Chalo, Gilbert reagents you have studied well. Now you tell me which one is correct. તમને આમાં કયું કરેક્ટ લાગે છે? કયો ઓપ્શન ના આવે એ કહો.
એ સર
એક કરેક્ટ. બરાબર. સિમ્પલ છે. સી આ ફર્સ્ટ રિએજન્ટ જે છે એમાં અહીંયા કોપર સાથે જે પાર્ટ્સ જોડાયેલો છે આ ડબલ બોન્ડ વાળો કાર્બન, આ જે કાર્બન એને અહીંયા એડ કરવાનું. બરોબર છે, ફ્રન્ટ સાઈડથી. જે આમાં પણ છે ને આમાં પણ છે જુઓ. પછી સેકન્ડ ટાઈમ જે અહીં કાર્બન એડ થઈ એની અપોઝિટ સાઈડથી આ ગ્રુપ એડ થઈ, એટલે આ જે આલ્ફા કાર્બન એડ થશે ધીસ ઇઝ બીટા, ધીસ ઇઝ આલ્ફા. બરોબર. પછી જે સેકન્ડ ટાઈમ આલ્ફા કાર્બન એડ થશે એ આ રીતે એડ થશે અને અપોઝિટ સાઈડથી. અને આ જે જ્યોમેટ્રી છે સીસ અહીંયા, ધીસ ઇઝ ધ સીસ ડબલ બોન્ડ, એ સીસ જ રહેશે, એ સ્ટીરિયોકેમિસ્ટ્રી બદલાશે નહીં. આમાં જોશો તો એમાં સીસ જ છે, બટ આમાં ટ્રાન્સ થઈ જાય છે જુઓ. બી ઓપ્શનમાં આ ટ્રાન્સ થઈ જાય છે, આટલો જ ડિફરન્સ છે, વધારે નથી. ઇટ ઇઝ ટ્રાન્સ, સો ઇટ કેન નોટ બી ચેન્જ. બાકી કંઈ છે નહીં બીજું. ઇટ્સ ટ્રાન્સ. આમાં સીસ છે બટ અહીંયા બંને સેમ સાઈડ આવી જાય છે, બંને ડાર્ક લાઈન છે, સો ઇટ કેન નોટ કમ. સો કરેક્ટ વન ઇઝ એ. Answer become option number A. So this is about applications of Grignard reagents. Now rest of the oxidizing reagents we will going to finish tomorrow. Thank you very much.